using a number line is a handy way to represent visually the span of numbers, whether they're integers or non-integers, it doesn't matter. You can kind of see the whole run of integers within a given section of the number line. So a number line, usually when you see it drawn, you're going to see it drawn something like this. So it looks like an axis, and that's not a coincidence because coordinate geometry is just two number lines put on top of each other pretty much. And somewhere in the middle, you'll see something like 0, maybe. You could see anything, but generally we'll see 0 in this case. And then you'll see tick marks going in both directions. So 1, 2, 3, 4, 2, 3, 4. This side being negative, this side being positive. And then we can label these. Maybe they'd be labeled in this case 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So notice as you move to the right on your number line, the numbers increase. They get larger in magnitude. And this is true as we go from a seemingly larger negative number to a smaller one. Actually, as we mentioned in the integers video, we're getting larger as we go this way. So negative 1 is bigger than negative 4. Now, the absolute value of negative 4 is bigger than negative 1 because 4 is bigger than 1. But just in terms of the numbers themselves, negative 1 is bigger than negative 4. So we increase as we go to the right, and we decrease as we go to the left. We could also take a segment of this and zoom in. So let's take this segment right here, kind of blow this up itself. And like I said before, we can use non-integers. So again, we could have 0, and we could put another 4 points. But this time, we would see maybe fractions. So we'd see a quarter, a half, 3/4, and 1. And of course, you'd never be required to draw a number line on the SAT because there'd be no way for them to test that. But they certainly might give you one. You'll have to interpret it in a certain way. So here's another kind of number line. Notice it's with fractions. So what kind of questions could they ask you? Now, we go into this a lot in the SAT Math Tactics series, as I reference here, but some questions could be, could require you to interpolate points. So if I say, what is the value of that point? You'd have to say, well, it's about, halfway between 2 and 3, so it's about 2.5 or 2.5. And similarly, I could put a point right here and say, approximately what is the value of that? Now, you could say, well, relatively, it's bigger than negative 1/4, but smaller than 0. That might be useful enough. Or you can say, well, it's in between negative 1/4 and 0, so if I kind of half negative 1/4, I'll get negative 1/8. You also could think of it as, well, this is also the same thing as negative 0.25, so I need something in between negative 0.25 and 0, so something like, in this case, negative 0.125 or whatever. Right? But the point is you need to be able to look at a number line and figure out the values of points if they're not explicitly labeled for you. And that is what is being referenced by this part right here, estimating unlabeled points. We can also do operations with points. So let's say I gave you an x and a y. So I said, here is an x, and here is a y. And I said, what is x minus y? As you can see in this question. Well, we look for the value of x. The value of x is 3/4. And we ask, what is the value of y? Well, it's negative 1/2. So I subtract negative 1/2, add those together, and I'm going to get, well, we got to do a little messing around with this. So it's plus 2/4 because it's subtracting a negative. So this would be 5/4 in this scenario. So again, you just read the numbers off the line and do the operation. Now, sometimes they'll throw absolute value at you, and this is particularly true on the hard questions. So maybe in this question, again, if we had absolute value of x minus absolute value of y, we would have the absolute value of 3/4 minus the absolute value of negative 1/2. And we'll talk more about absolute values specifically later. So this stays as 3/4, but this becomes positive. So now we're actually going to subtract 1/2 because we're going to be subtracting a positive 1/2. So in this case, we're going to get 1/4 as the answer. One last note on a particular kind of question we might see, and it's all about finding the jumps. And we'll see examples of this in the SAT Math Tactics series, I believe. Imagine we're given this number line, 5, 2, 3, and 30. And we want to know what is the value of, let's say, this. Probably shouldn't have used yellow, but okay. What is the value of this? The key to this is two steps. Step 1, find the distance from two numbers you know. So notice we have a 5 and a 30. So we subtract 30 minus 5, and we get 25. So there's a distance, so to speak, of 25 between these two numbers. Then we count the number of jumps between the two numbers, not the number of hash marks, because that's not quite right, the number of jumps. If you count the number of hash marks, it's going to give you one less. So we count the jumps. Well, how many jumps do we have to get from 5 to 30? Well, it's 1, 2, 3, 4. Okay, so I go ahead and count those jumps. Actually, let me add another one because I realize this number is not going to work out very well. Let's add that one here. So it'll be 1, 2, 3, 4, 5. So there are 5 jumps in between 5 and 30. So now we divide our distance by 5, and we get 5. And this means each jump is 5. So we know that this value is going to be 10, 15, 20, 25, and then, of course, 30. So the answer to this one would be 25. So that's just a minor question that you might see on some SATs.